Welcome to module 40 of database management systems. This is for course summarization. This is the last module of the course. So, I would just start with doing a quick recap of what all did we cover and what we expectedly learnt. In the week 1, we talked primarily of introduction to database management system and the relational model, which is the foundation of a database system. In week 2, we started off with query language SQL at an introductory level and then at an intermediate level, which are really the first major aspect of a database, particularly a relational database that a student must master. In week 3, we continued with the advanced SQL and did the aspects of modeling from specification in terms of entity relationship model. In the next week, we did the design issues, which was really the involved part and possibly the most important aspect of the relational database design beyond query coding, being able to write queries. So, this is based on dependency and different normal forms, and I am sure you have spent a good time on mastering these. We followed up in week 5 with application design and discussing aspects of storage structure, how will actually the data items be stored in the different memory and disk structure. In the following week, in week 6, we discussed about indexing and hashing for making the accesses really efficient. In week 7, we did another critical aspect of database systems, that is how to make transactions work concurrently. So, we defined transactions and defined what is concurrency, and then we took into different critical aspects of serializability, that it is possible that we can execute transactions in a manner so that their instructions are intermixed, but then even in that case they actually produce a result which is as if these transactions could have been executed in the serial order. And we talked about the issues of recoverability in this respect, and we specifically looked at different protocols, particularly two-phase locking protocol for managing this kind of concurrency and the evils of deadlock that may happen when you do a concurrency, and how simple protocols like time based protocol can handle that. And in the current week, we have dwelt with different strategies of recovery, particularly log based recovery, and we have touched upon query processing and optimization. So, this is you have got a very first level overview of this course. This is in a limited time and with limited number of assignments. So, you will just get a first level idea. This is not to make you really an expert of database systems, but this will certainly get you started well in terms of the database management programs, in terms of your taking up advanced courses later on, or in terms of actually taking up a job in different database area. So, given that in this current module, I would discuss about few things beyond the textbook. Actually, the space of databases, RDBMSs are quite crowded. There are a lot of RDBMSs you will see. So, I will just take a quick look in terms of the common RDBMS systems, and there had been a number of queries on the forum and in the live session about that. I will also touch upon, we would like to discuss about non-relational database systems, which was not a part of the curriculum that we did here, but we will just present a brief overview. And then finally, I would like to conclude with what should be the road forward for you, presenting you a kind of a skill profile matrix to show that what skills you must pick up to actually get a job of certain profile, and what are the companies that you might look at working for. So, starting with the common databases, there are several relational database systems. So, in this slide you summarize basically what are the different aspects of relational database systems, which you have been discussing so far. So, this is just a summary of that. Now, these are the common database systems. So, I have chosen the ones which are most widely used, most easily accessible, and kind of large companies use them, large databases exist on them. So, there are primarily two classifications. One is a set of database systems are commercial, Oracle from the Oracle Corporation, Sybase from Sybase Corporation, which is now SAP AG, DB2 from IBM, SQL Server from Microsoft, and the recent entrant to that who is making a regular ripples is Teradata, which is a joint database systems from Caltech and certain group of Citibank. So, if you are working for a company who subscribes to any of these database software, then you should be able to use them and understand what all you can do. But if you are working with smaller companies or you are working as a student, then you will need to use some of the database systems which are free or are on the GPL licensing or open source. So, most prominent amongst them is Postgres SQL, which is from a Postgres Global Development Group. So, these are non-commercial the software in the sense that you do not need to pay for them, and they are on the GPL, and some part of that would be open source as well. And a very commonly used is MySQL, which was originally from a Swedish company called MySQL AB, but now it is acquired by Oracle Corporation, but it still does not, you do not need to pay for that. So, these are the databases systems to primarily look for, and besides that there are some other database systems which use certain object oriented features on top of the relational features. So, if you look in through these, then in most cases you will find in terms of the gross functionality of the kind of SQL that you can write, a large subset of the SQL that you can write on databases maintained through these database systems will be same. So, what you have learnt here would be applicable irrespective of which database, which of these database systems you are using, but of course, there are specifics which would be different amongst them. So, in the next couple of slides, I have for on each one slide, I have given a brief background about the particular database system. So, that you know how stable, how old, or what are the basic nuances of that database system. For example, Oracle started in 77. So, you can say it is a 40-year-old database system. The latest version is 12C, and these are the different supports that it has. Sybase also started in 1987. So, that is almost 30 years, but it is less less vibrant right now. The last stable release happened in 2014, about nearly more than 3.5 4 years ago. And but Sybase is has been a very good database systems for programming through APIs, and it has really good support for that. DB2 is also a very old, possibly the oldest surviving database systems, which started in 1970. So, when almost the EF code of the Boyce code normal form published the data manipulation schemes from IBM. So, this is also a very widely used, last release 2016. Microsoft started a database systems in 1989, last release happened last year, and that is very widely used if you are particularly on Windows system. It is one of the most popular one in terms of the Windows operating system. Teradata is relatively new. It was released in 1984, and it's but it's one where lot of new developments are still happening and new experiments keep on happening, and the current version is Teradata 15. And in terms of the free or open source GPL databases, Postgres started in 1988, about 30 years back, and as I said, this is has a release even of this year. So, it is a very vibrant system. MySQL, probably most widely used amongst the free community, among the open source community also. where the first internal release happened in 1995, the recent releases happened this year. So, these are the common database systems that you will come across. So, I mean, given the organization that you are working with, first find out which database system it uses and then look into the specific manual for that and specific features. Beyond these relational database systems, also there are certain database systems which use object oriented notions in that. So, if you are familiar with object orientation, then you would have understood that the relational approach does not keep things object oriented, because you are always flattening out in terms of attributes and you are trying to look at the attributes. But it when, for example, when you want to model the same thing in terms of a C++ or Java program, you would like to look at a course as an object, as a class. So, you would like to look at instructor as a class, you would like to look at teachers as a kind of class and their instances. So, there has been attempts to give a object orientation kind of layer on top of relational databases or define things in that way. Objectivity DB, O2, object store are some of the examples, but unfortunately these have not been as popular as the regular relational databases. So, if you happen to use any one of them, then you should be cautious that you really know why you are using it, and you will be able to go a long way in terms of that. Now, when you come across a particular system that your company or your university needs to use and you would like to choose, then it will be good to look at the different aspects of that system. These are here are some of the parameters on which these database systems vary in a minimal to a very large extent in terms of what operating systems it supports, what are the fundamental features, what are the limits. For example, every database sets a number of limits in terms of the index size, in terms of the table size, and a whole lot of that. How are the tables and views created, what kind of restrictions you have that, what kind of indexes support, the capabilities, the data types, the different databases support. We have talked about a very limited set of data types in terms of SQL, but in an actual commercial or even open source database, the data types could be wider than that. What kind of other objects, partitioning, access control mechanism, access control is very important for ensuring security. And finally, what kind of programming language support do you have? Because as we have seen in the application development module, that it is not enough to just have a database firing SQL queries. No application user will actually fire SQL queries. The application user needs an GUI possibly or a text interface through which it will put queries in a different form, and that needs to be processed by taking it to the database engine. So, you need possibly an interface which is in terms of C, C++, Java, Python, this kind of programming language. So, how do you connect to or embed embed your relational query into different languages that differ between different database systems. So, these are the parameters that you must look at. In the next series of slides, which I will not discuss really, because these are more like data, but here I have given a compilation of different on different aspects, how do these common database or DBMS systems agree or differ. So, this is like a slide which shows what are the operating system support for different databases. So, if you are for example, working on Android, then you can easily make out that you do not have a choice to use SQL Server or to use Oracle, but you can use Sybase, but you can use Postgres and MySQL. Actually, if you look into these two columns, the rightmost columns which are for the open source databases, you will find that they have the widest choice in terms of operating system. In many aspects, you will find that these free database systems have a better options for you. Obviously, when it comes to really the core of database systems in terms of really supporting very large databases, really supporting very fast operations, really supporting very secure applications, you might need to only work with commercial software because they offer that, but otherwise for a large number of common medium scale or low cost applications, the free database systems Postgres and MySQL are really good options. There are different such features. The basic features are compared here. I have compiled different limits of different database systems here. So, you can see in terms of maximum row size, columns per row and so on and so forth, how do they differ. So, if you are making a choice in terms of what database you will use, you can use this information. This talks about tables, views, the type systems, what kind of typing is used, the different data types that are used are given here. The index mechanisms are discussed here, the capabilities of the database, what it can do overall, other kinds of objects that it supports, the different partitioning mechanism, the access control, which is critical for ensuring good security and good management of that database, are given here. So, these are kind of the different across different features. This is parameters, this is how they compare. So, well, this is for your reference only, this is not for your assignment or examination, but I just wanted to have a view that with all the theory and small hands on that you have seen, when you go to the real life, what are the expected things or what are the expected system that you will have to work with. Now, let us move on and let me just briefly talk about a group of database systems which are non-relational, and of course, I would warn you that the basis for these DBMSs are not covered in this course, is beyond the course, but just for your information and to keep you in tune with what is happening frequently around the industry today. So, the non-relational database systems have arisen from what you all must have heard of is the whole aspect of big data. Big data, as the name suggests, is certainly voluminous data, complex data, and now the question that you might have is if I have done a good relational design, if I have a good RDBMS, can I not handle big data? The question here really is, big data is not only about volume. So, volume is only one aspect which is really large. So, big data typically are characterized by certain V's. So, these are not any very standardized characterization, but these are more commonly accepted ones. So, one is volume, that the quantity of data for a big data situation has to be very large. Now, again, what is very large is again a subjective question. Some you can say that a million record is large, someone else would say no, million record is small, it is actually 10 million is large. Some might say that it's a database need to be petabytes to be large and so on, but these are all subjectivity, but it is large, has a voluminous existence in certain sense. There has to be a different variety, different types of data. So, all that we have seen in the relational database is basically your strings and numbers. If you look at it in different ways, we have seen whatever we have dealt with in all these through all these 39 modules so far, they are primarily about strings and numbers, but nothing else we have not. But big data can be about free text, it could be about natural language comments. You are regularly writing comments on your Facebook. So, those Facebook comments are phrases, and if I want to make certain query based on that, if I want to make a query that okay, how many Facebook users has commented on the success of Virat Kohli as a captain of India. If I want to make such a query, then the question is how do I do that, because it is not something where you have the information in a very structured way. There is no relational schema which says that well, the values are put in terms of Virat Kohli having done very good, moderately or marginally, or the Indian captains are successful, not successful, and so on. These happen in terms of various texts, phrases, clauses that we write. So, variety is a major issue. Then it could have audio, images, video. So, big data includes all of that. The third V is about velocity, that the processing speed may need to be really fast. often in big data often we say that the processing has to be real time, which means what is real time? Real time is basically that from the time I fire the query and to the time I get the result, there is a fixed time limit within which it has to happen. So, if I really want to do a railway reservation, that also is a kind of real time, but that is not very critical, because it is okay if I get the reservation done in 1 minute. It is also okay if it takes 5 minutes. It is good if it can happen in 10 seconds, but I do not ever need it in say 20 millisecond. So, but when you talk about real time, it could really be about getting all these processing done in millisecond, microsecond, nanosecond and so on, and those kind of real time systems with a large volume of varied data is a big challenge. So, those are the challenges of big data. Then there could be variability, inconsistency of the data that you are, because maintaining integrity is a big problem. There could be issues in terms of quality of the data, that is called veracity. So, actually these characteristics that I have put, there are a lot of debates in terms of that, or many people take these three and say that these are the 3 V's of big data. That is the 3 main characteristics, but of late more and more people are also considering variability and veracity are as the characteristics of big data. Now, as it happens is, if you look into these requirements and what you have a fairly good idea of relational databases, now what they can do, how to design them, how to query them, how to implement them. You will understand that it is not easy to meet these requirements using the relational model. So, we need the non-relational databases to effectively support big data. That is the one major reason that you will need big data. So, the non-relational databases, certainly as the name suggests, do not follow relational model. They offer flexible schema design. The schema may itself change while the database is evolving, which is not the case in the relational. Schema is fixed, only the data can change, but here the schema itself can change. It may be able to handle unstructured data like natural language comments, like images, like audio coming in, which do not fit nearly into your table structure. Some of the other features are they are typically open source, because still in an experimental stage and needs to be scalable. And some of the popular ones are these are the names you must have heard about, at least some of them, like MongoDB, like Cassandra, like HBase and so on. Now, again in terms of the non-relational database, it does differ in terms of all non-relational databases are not of the same type. There have been 4 different styles or strategies to actually realize these non-relational databases. They are called key value store, graph store, column store and document store. They are also known as NoSQL databases. I personally find the name NoSQL a little misnomer. NoSQL does not mean that you are strictly prohibited from not using SQL in these databases, but I would rather like to read it more as NoSQL means that it is not only SQL. Like in a relational database, you can use only SQL and solve problems. Here you need to do lot of other things beyond that. So, here is a quick comparison between the relational and the non-relational in terms of the flexibility of the data model. Relational is very structured, when non-relational has to have handle unstructured data, semi-structured data, and therefore, it has to be flexible in terms of the data model. Cost, complexity and speed, faster, less capable, but cheaper and less complex, but in non-relational you are talking about much more database operations, highly complex in internal structure, usually costlier. Performance and scalability, certainly non-relational ones need to be better scalable. Consistency, you have a very strict consistency rules in relational, but in non-relational you use some kind of eventual consistent system. So, maybe not always, not everything is consistent in that way. Enterprise management and integration, relational fits very well into, because it has been around for, as you have seen the little bit of history of all these common databases. It's more than 40 years that they have been around. So, they easily fit into the IT stack, whereas non-relational is still on the in the agile form of development that's becoming more and more common. It fits into the cloud based development and so on. So, these are some of the distinctions that exist. And these are the different types of NoSQL databases. There is a key value store strategy, Redis and Memcache DB follow this strategy. Graph store is used by OrientDB and Neo4j. Column store is used by Cassandra and HBase. Document store, MongoDB, Couchbase, they use document store. So, these are this is not just about going deeper into what they are or how they are distinguished. I just want you to have an idea that well, these are different from the relational databases. They can do lot of structured handling of unstructured data. They can actually use a scalability, a volume, a variety which is relationals cannot do, and but there are different principles for actually implementing them, and there is a deeper. So, if you are interested, you can take specific courses which deal with the big data and prepare yourself for the bigger challenges ahead. I have also done similar to the relational database. I have presented here a tentative comparative study between these different NoSQL databases in terms of what is the context in which you use them, or now while you are doing this unstructured data handling, there will be a lot of data which is also structured. So, how do you along with this NoSQL, how do you handle the relational data with these databases? How do the performance compare between these different NoSQL databases, and based on all that you can make some judgment. And it is very important to in today's time, naturally knowing relational databases, the foundational ones are very important, but it is always good to look forward, be with the time, and I will urge that if you have started growing interest in handling of data, do take specific courses on big data and NoSQL databases. I will end this discussion with a very simple skill job profile matrix, which will give you some idea in terms of you can use it for a certain kind of self assessment as well. So, let me just explain the structure of this matrix. What I have tried to do is here, I am sorry, here on the left I have given different typical job profiles. This is, if you look into LinkedIn, Naukri and all that, you will find these kind of profiles being. So, at the lowest level there are application programmers for which typically 0 to 4 years of experience are asked for. Then the next level, this is your kind of your career progression also. If you choose to take up databases as your primary job profession. This next level is a senior application programmer, which requires 2 to 6 years of experience depending on the organization and depending on your skills. Then you move on to database analyst or architect, which you happen in 4 to 8 years of time. And on a little different track, because these are primarily in terms of application development and hierarchy on that, and the other is an administrator track who actually administers the database in an organization, controls all that is happening in different database applications. Typically 8 to 10 years experience is required, and some of that. So, these are about actually in terms of profiles that are related to applications, and this is a profile which is related to, if you really want to become a database engineer, in the sense that you want to make changes in Oracle, you want to make changes in say MySQL, you want to make changes in say MongoDB or say the relational one, say the Sybase. So, if you want to become a database engineer who changes the database system itself or develops the database system itself, then this is the kind of background you will need. This is a kind of number of years you will need, and of course, it is not a single grade, there are multiple grades, junior, mid level, senior and those kind. And last, which I have shown in different color, are the whole set of profiles which relate to programming the big data, analyzing the big data and so on, where at present it's companies are typically asking for 0 to 6 years of experience depending on the actual skills that you have. On this side, I have shown a whole grouping of skills. This is the first basic level, that you must understand specs and schema. Without that, you cannot do any of this. And you must have the skill for coding in SQL, the DML part significantly. Without that, as you can see, you cannot pick up any of these profiles. Whereas, if you go a little senior, gain in experience, then you should be able to analyze specs, you should be able to design schema, do normalization, and get into this. So, at a very initial level, you may not be expected to do all of that schema design and normalization by yourself, but it will be good to be able to do that, but well, there will be seniors to help you, but if you once you become a senior application programmer, that becomes onward, that becomes a critical skill to have. Then the next level would be in terms of application or database architecture management, deciding on how to index, performance optimization. So, between these two, there will be certain overlaps. A senior application programmer, in addition to doing this, might do some of these optimization techniques depending on how competent he or she is, or some database architect may focus only on this part, but these are the typical skills that you need. But to be a database administrator, you need all of these skills, but you are specifically administering a certain organizations, enterprises whole database system. So, it is just not one database application, but a whole lot of databases and whole lot of user groups, security, network connectivity and all that. So, that needs certainly bigger experience. You can see that the experience level is much higher, and the skill sets. If you want to become a database engineer, that is not focus only on the application side, but also have some more understanding in terms of actually working in the internals of the database systems, then you need whole lot of additional skills like good knowledge in algorithms, in architecture, in compiler, all of that. Only then, and coupled with all the database knowledge, then you will be able to work as a database system engineer. And in the emerging area is what is big data, where you need to have, now of course, I am saying this is 0 to 6, it could be 0 to 8 kind of, not more than that, because it did not exist quite a long time ago. But you need to have a basic level of at least this much of the relational database understanding and knowledge, but what is critical is a whole set of other skills, like you must be aware with big data, the data mining, warehousing strategies, machine learning is often very useful in this kind of big data applications, Python programming, TensorFlow, all these become critical. You have to be a good programmer in any case, I mean not only just an SQL programmer, you have to be a good programmer in C or C++ or Python or these, but that is a very emerging area. So, if you can acquire a little bit of besides database, you say that the basics of the database, along with that if you pick up few basics from here, you will be able to enter into this space, and that will give you a very bright future in my view. Otherwise, you can focus on the application programming stack, as I have mentioned. So, this is the basically skill profile matrix that you have, mapping that you have, that you can focus on. So, finally, before I close, here are glimpses of companies that are in the very active in the DBMS space. Really any big organization you talk about, they have consultancy projects, product development, different database management, backend services and so on. So, DB application development, I have listed some around 20 companies, but there are really hundreds of them. Almost any big organization in any area you think of, they require databases. So, in terms of database application programmer and senior programmer and to some extent architect, you have a wide range of jobs available, which you may just grab if you have been able to study the basics of the database. The second group of companies which I show here, these are system development companies who are actually working on the new DBMS products and services around that. So, these are companies like Oracle, Teradata, Microsoft and so on. Naturally, these are big companies and you need lot of more skills besides the database, like I said, algorithms, programming and all that to crack a job here. And here are some of some companies which I have mentioned, but there are many others who are focusing on the big data space. So, I have tried to these may not be absolutely accurate, because these are all collected from different sources, but these are the different companies and the kind of non-relational database that they are focusing with, working with. So, if you pick up certain skills in those in a certain non-relational NoSQL database, then you can target the corresponding companies better or other companies, and you can see that all new generation companies, the companies who are working for products for the next 10-15 years are in this space. So, there are whole lot of opportunities for you all. If you prepare little hard, then job will run after you, will not have to run after the job. So, with that I conclude this course. Couple of final words, the hygiene words: read the DBMS textbook thoroughly and solve exercises. There is no shortcut to that. There is no other way to master the course other than this. You must practice query coding as much as you can. Practice database design from specification. We are releasing a tutorial on this, where for a hospital management system we are showing from the specification how you can do the initial schema and the refinements, and finally, how can you implement it using MySQL. So, do similar practices very heavily. Keep in mind the database, the knowledge of database system alone will not be good enough to get a good job, get a good placement. So, develop good knowledge in programming, data structure, algorithms and discrete structures. These are the minimum required around the database systems, which will really make you powerful. And if you need, we are there to help you. As long as the course is on, the forum would be on, you can post in the forum. Beyond that also, if you need help, please ask for it, mail us, and wish you all the very best with your course, your examination and the future course of your profession in life. All the very best.